All right, pre-calc, and welcome to the start of Chapter 5. Just kind of to let you guys know, Chapter 5 is a pretty lengthy chapter. It's going to take us all the way into December. So I just want to remind you as we go, just do the assignment each day. There's going to be something small for you to do. If you do it each day, it won't be that much work. If you wait until December 1st to start it all, it's going to be a lot of time, a lot of confusion on your part. So please just do things as you go and let me know if you have any questions. Also, we're going to go ahead and start Chapter 5. So if you were not at school Thursday, you can either print out this packet. It's found in the It's Learning folder for Chapter 5, or you can do your best just to take notes on paper, and then on Wednesday when you're back at school, you can get a copy of it. So to start off Chapter 5, we're going to talk a little bit about what is a function. Okay, hopefully you remember way back in August we talked about this, and so kind of to put it in just a slang version of what it is, it means our x's can't cheat. Now what I mean by that is each x value has to have, Alright, so our x's can't cheat. Each x value has to have its partner, and it only can associate with that partner. So if we look here, it says tell whether each relation is a function, right? Yes or no, and explain. So this first one, -1 goes with 7, then -1 goes with 8, and then -1 goes with 9. Since the x value -1 has 3 different partners, okay, it goes with 7, 8, and 9. If it's more than 1, then we have a problem. So no, and the reason -1 is paired with multiple numbers. All right, so take a look then at example B. And here we have -5 goes with 3, -4 goes with 3, -1 goes with 3. Each of our x values is unique, and so if that is the case, we know that all of them only are paired with one y. So yes, this is a function, and our reason no x's repeat with different y values. All right, so the next thing we're going to talk about today, that's a function. Now our inverse of a function. The inverse occurs when our ordered pair, so if we have an ordered pair, we know it's x comma y. And the inverse is when these numbers switch places. So they switch, the x becomes the y becomes the x. So kind of our hint, we just flip the x and the y. And nothing else changes. If it was positive, it stays positive. If it was negative, it stays negative. So maybe make a note for yourself, no sign changes. Just switch the x and the y, and that is all there is to it. So if we look here, this first one, we got these 4 points, 2, 5, 3, 8, 4, 11, 5, 14. The inverse of this, the x and the y switch, so instead of 2, 5, it becomes 5, 2. Instead of 3, 8, it becomes 8, 3. Instead of 4, 11, it becomes 11, 4. And instead of 5, 14, it becomes 14, 5. And that is all there is to it when we're finding our inverse. Okay, so example 2 here only has 3 points, but it's the exact same thing. So some of you might notice, if we look at this original one, the function here, 1, -5, 3, 2, 8, -5, that is a function. When we take our inverse becomes -5, 1, 2, 3, and then -5, 8. So the original was a function. The inverse would not be a function. It's the inverse of the function, but it's not a function because -5 goes to 1 and -5 goes to 8. All right, and then example 3, same deal. All we're doing is switching our x and our y. And finally, negative 37, comma 1. All right. And we are done. Now, sometimes we're given points, like what we just did. Sometimes we instead are given an equation. So if we look down here, it says in example 4, find the equation, or find the inverse of y equals 2x plus 3. So when we're finding the inverse of an equation, two things we got to do. First, we're going to switch the x and the y. And once we do that, step 2, all we got to do is solve for y. So we want to isolate the y value. And then we're done. So we look over here, we first step, switch the x and the y. So x and y switch places, we get x equals 2y plus 3. And now we want to get that y by itself. So I'm going to subtract my 3. I have x minus 3 equals 2y. Divide by 2. I'm going to rewrite it in the other order, but y equals x minus 3 divided by 2. And we are done. That is all there is to it. Now, what does an inverse do? So we're going to show that over here. And basically what we can do is, let me zone off an area for us. We're going to just pick any value. So we can pick a value that we're going to plug into our original function. So in our case here, I'll use x equals 10. Could have used any value. And then I just plug it into that original for x. So y equals 2 times x, so 2 times 10 plus 3. And we know that 2 times 10 gives us 20. So 20 plus 3, y would equal 23. Now we take that and we plug it in to, well, we switch it. It becomes the x because with our inverse it switches. So if x is 23 and we plug that value into our inverse, we will solve, okay? And we should get the same value we had. So y equals, then we plug it into the inverse right up here. So y equals 23 minus 3 divided by 2. 23 minus 3 is 20 divided by 2. Y equals 10. And you see that is the same value that we started with. And we know that we did it correctly. So let's do it again. We don't always have to check it unless it asks us to. But we do want to find our inverse here on example 5. So it says find the inverse of f of x equals x squared minus 9. Now the f of x might give some of you pause. F of x just means the function with respect to x, which is the same thing as our y. So we know this is the same as the y, which means when we do step 1, we switch them. We're just going to get x equals y squared minus 9. Go ahead, then we add 9 to both sides. So we get x plus 9 equals y squared. And from here, we'll take the square root of both sides. And we'll get y equals the square root of x plus 9. And we're done. All right. Now example 6 looks different. It says find f of negative 1 if f of x equals 2 over x plus 3. But remember, we already said that f of x just means y. And f of negative 1, that just means the inverse. Okay? So f of negative 1 is another way of saying the inverse. So all we have to do here, once again, we'll switch our x and our y. Now this one maybe is a little weird because the y is on the bottom. We're going to multiply. If we multiply that by the same thing as the denominator, that'll cancel out. But if I do it on one side, I also have to do it on the other. Now, we could multiply that x in, or we can just leave it as such and now divide by x. So if we divide by x on one side, we got to divide on the other side. These will cancel out. We're left with y plus 3 equals 2 over x. And final step, then subtract 3 from both sides. And we'll get y equals 2 over x minus 3. And that would be our inverse. So the final thing I want to do example 7 today, it just says choose any two numbers to show that these functions are inverses. So all we got to do is just pick any number, and then we're going to plug in the x value into f of x. Whatever we get, we're going to plug in that y, or we're going to switch it back to the x value and plug it into f of -1, or the inverse. So our first one, we're going to choose anything. So say I pick x equals 5. Okay, you could literally chose any number you want. Okay, you can use 0, you can use 1, 2, 3, 4, 5. I'm choosing 5. So if I plug that in, and remember f of x is the same as y, so we get y equals 2 times x, so 2 times 5, plus 4. 2 times 5 is 10, plus 4, and y will equal 14. Now that switches and becomes our x value, and we're going to plug that in right here. So we'll get y equals 1/2 of 14 minus 2. And once again, we can use a y instead of f of -1 of x, the inverse. We're still using a y at the front. Half of 14 we know is 7. And 7 minus 2, y will equal 5, which is what we started with up there. So good. We've shown one time that it works. Now it asks us to choose any two numbers to show it. So we want to show it one more time. Okay, so this time, once again, you can choose whatever you want. I'm going to use x equals 3. Okay, I don't care. If you want to try it with a different number and see if you can do it, that's fine. You can use any number you want. So we plug in a 3, and y equals 2 times x, so 2 times 3 plus 4. 2 times 3 gives us 6 plus 4. And y will equal 10. Then we take that value and we plug it in, and we have x equals 10, and we plug that value in. Half of 10 would be 5 minus 2, gives us y equals 3. As you can see, that was our original, and we have shown it 2 times. So that's all I have for you today. Be sure to do the brief assignment. It explains what to do in It's Learning. And go ahead, take care of business. And remember, tomorrow we don't have anything. So tomorrow is our day off. But then Wednesday we'll be back at it with you guys at school. So hope you guys have a great day. Bye.